Today on the bench we have a Mirage, God, what is this, 9900, which is basically a Galaxy 99. Customer sent this in to have basically all the modifications that have ever been done to this radio undone. So actually there's some bunch of parts laying over there, crap that I've removed. High power mods and audio, just all kinds of shit that's been done to this. Re-enable the AMC, ALC circuits, the whole 9 yards. I just happened to be getting ready to, thought I had all of the modifications removed. Figured, okay, it's about time to do an alignment on it. Had everything hooked up. Just wanted to see how the radio was working before I actually started the alignment to make sure there wasn't anything else that needed to be troubleshot and repaired before I did the transceiver alignment on it. And tried it on AM, FM, looked good. Tried it on upper sideband, looked good. Flipped over to the lower sideband, and what the hell? So it's got a weird problem. Now, I haven't contacted the customer yet, so I don't know if he actually uses sideband. I know a lot of people have these radios like this. The only thing they ever talk on is AM, so he may never use sideband, and may not know there's a problem. But here's what I have. So we have the communications test set, turn the volume down here, hooked up. It ends up taking a tap off into the spectrum analyzer. So in AM, and turn the mic gain down here, key to mic, you can see there's our carrier, turn the mic gain up. So you can see, and there's our two sidebands, one on either side of the carrier. Flip over to upper sideband. There's the suppressed carrier. It's not suppressed so well. Haven't done an alignment or anything to this yet. But if I modulate, you'll see one peak pop up over on the right side. That's the upper sideband, and that means that the carrier and the lower sideband have been suppressed. Everything looks fine. That's what you'd expect to see on sideband. Flip over to lower sideband. Turn the mic gain down, key the mic. So you can see there's some crap down there, so it's not completely suppressed, but you do have suppressed carrier. There's no AM carrier. Now look what happens when I whistle into the mic now. Yeah, there's an upper sideband, there's a lower sideband, and the AM carrier comes back. What the hell? Yeah, exactly. That's what was going through my head. And actually, now that I think about it, because actually in AM, okay, so if we watch, you're going to see when I whistle into the mic, you're going to see a sideband pop up on each side of that carrier. Now, just watch the spacing. When I flip to upper sideband, you'll basically just see the carrier and the opposing sideband will disappear, but that upper sideband will just stay there. When I do it on the other direction, so actually that would be yeah, that's weird. So actually, the lower sideband offset, it's actually the upper sideband with a carrier and a sideband that's even lower. The lower sideband's even down even farther. Yeah, that's even weirder now that I think about it. So let's take a look at that. Yeah, so because you saw it had AM, be the big spike in the middle in AM. You'll have the lower sideband and the upper sideband. When I switched to upper sideband, basically that disappeared. You end up with the upper sideband. And then what should happen is when you go switch to lower sideband, that should happen. So you should lose the upper sideband, the carrier should go away, and you should be left with nothing but the lower sideband. Actually, what happens is that's there, you end up with a carrier, and actually don't have enough fingers on a hand, you end up with another one down here. So actually, that's kind of like an upper sideband, an AM carrier, and the lower sideband's actually falling, because I have the bandwidth set on the spectrum analyzer to 10 kilohertz, so that's one CB channel. So actually, the lower sideband in that mess is actually falling off the screen, so it's starting to, fall into the next channel down. Yeah, so I got some troubleshooting to do here. I just wanted to show that before I get into it and get, taking a look. Actually, I did a little bit. It's not band selector switch or mode selector switch related, because it is switching. Obviously, it's suppressing the carrier, without modulation. So it's in lower sideband. I've even taken some voltage measurements. I've got 8.5 or 6 volts at the switch. It switches over fine. Yeah, I've got. I'm going to have to do some troubleshooting there because, and it could be. There's still some resistors bodged on the bottom side of this radio. I wasn't really sure what they were for, so I kind of left them for right now. But yeah, I may need to really. There's some other. There's 2 there. There's 1 here. See, I need to see what the hell's going on here because that's definitely not right, and I can't let it go like that. It's just wow. But that's something I've never seen. I've never seen a radio do that. I've seen sideband disappear, have sideband problems, but I've never seen one where the upper sideband was fine, but lower sideband had that weird. Yeah, and that's just strange. I just wanted to get that on camera so in case somebody else ever runs into this with a radio, let me do some troubleshooting here. I'll find out what the problem is, and that way I can show you. That way maybe save somebody else some time of having to troubleshoot this. Okay, so I got her fixed. Now I need to do the alignment, and what it ended up being was, right here actually, bad balanced modulator. So an AN612. Made by Panasonic. It's got the Matsushita logo on there. I think they're the only ones that ever made that. So yeah, I mean, that was a weird problem. I personally have never seen one that only affected. Now, don't get me wrong, I've replaced lots of these, have gone bad, but I've never seen one go bad that only affected one sideband. Because it's not like it has a pin for a lower sideband input and an upper sideband input. It just has a carrier input. It has an audio input. Basically, there's your voltage sources and an output. So it's not like this knows that you're doing upper or lower sideband. So it's not like the first pin's lower sideband, the second's upper sideband. And I could see that circuit going bad inside the IC. It was dependent on what sideband you were in. That's just really weird. I've never seen one that failed that only affected one sideband. So and the way I found that was, just basically look at the block diagrams. The same. You're going to do the same starting point you do with anything. You want the schematic, and somewhere in here should be a block diagram and a block diagram. That's the best place to start. For sideband, that's actually a fairly simple circuit. It's simpler than the AM in a lot of cases. Microphone is going to come through the mic amp. It goes straight from the mic amp basically to the balanced modulator. So here's the amplifier here, and here's the balanced modulator. And you can see pin 1 there. So basically it just comes out and straight into the balanced modulator. So all I did was scope the carrier input and the audio input into the balanced modulator, checked what it looked like in upper sideband and lower sideband, and it looked fine. Went to the output of the balanced modulator, checked it in both modes again, upper and lower sideband, looked completely different. Didn't matter so much what they looked like, because when you're viewing signals in the mixing process, they're going to look way different than what's coming out the antenna jack on the back. Anybody that works on radios can tell you that. Even in your amplifier circuit, as soon as you get back off of the final, all the stages before that, it's not going to look anything like a clean sine wave. It'll be all distorted, but through filtering in the next amplifier circuits and whatnot, you end up with what you want coming out. Well, the balanced modulator is no different. You're going to have really weird looking waveforms, but the point being, the upper and lower sidebands should look the same. If you put the same audio in and the same sine waves coming in as far as your carrier oscillator goes, the outputs should look the same too. They didn't. So that's pretty much the only thing there. So yeah, just stuck a new one in. So have it in AM. Look at the spectrum analyzer there again. And then I'll switch to, I'll just continue whistling and switch to upper and lower sideband. So you can see all those extra spurs have disappeared. Now, you may notice that the the lower sideband is actually to the left farther than it should be, it's out of alignment. I have not done the alignment yet. I want to do all the repairs on it first. It's very clear to see that it's out of alignment. The upper sidebands look like it's fairly close, but the lower sideband's definitely off by like a little bit over 1 kilohertz. And I don't know if maybe somebody tried to align this, because this thing has a lot of repair stickers on the inside of the cover where it's been worked on over the years. Almost makes me wonder if somebody tried to do an alignment on this and ran into a problem, not realizing, or they may not have had a spectrum analyzer. Because honestly, this is one of those things, it's hard to see that without a spectrum analyzer, that you're having weird problems at carrier, because you can't see a carrier and sidebands with an oscilloscope. You need a spectrum analyzer to see that. So I almost wonder if this thing's been doing that for God knows how long, has had an alignment done, and it was aligned incorrectly because of that problem. So that was it. So, if you ever end up having a problem, weird sideband problem, where one sideband transmits just fine, the other one looks like it still has a carrier, and both sidebands, that would be the first thing to check. Just check your inputs, the outputs. If you don't even really need to check the inputs, just hook up to the output of the balanced modulator, and if they look different in upper and lower sideband, it's a good chance it's going to be the balanced modulator's bad. So there you go. Hope that helps somebody out.